Hello friends, let us solve one physics paper in this video. Physics paper 2 062522 February March 2022. And our first question is, a student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The readings are shown. What is average period of the pendulum? In all, we have readings of 4 experiments. We will add all the readings, divide by 4 to take average of the 4 experiments. This comes to 18.4 seconds. 18.4 seconds is time for 20 oscillations. So we will find time per oscillation by dividing it by 20. Time required to complete one oscillation is 18.4 by 20, which comes to 0.92 seconds. So average time period, that is time required to complete one oscillation, is 0.92 second. Option B is the correct answer. Second question. A tennis ball falls from upstairs window of a house. What can be said about the acceleration of the ball if air resistance is ignored? A. It depends on the density of the ball. No, it doesn't depend on density of ball, and it also doesn't depend on mass of the ball. It increases as the ball falls. No, it will not increase. It will remain constant. So correct answer is option D. It stays the same as the ball falls. Third question. A car joins a road at a speed of 14 meter per second and accelerates at a rate of 4 meter per second square for 5 seconds. What is the final speed of the car? So what do we have here? We have initial velocity u 14 meter per second. Acceleration a is 4 meter per second square. Time t is 5 seconds. And final speed v we have to find. If we use formula v is equals to u plus at, we will directly get the value of final velocity v. Let us substitute all the values. We have final velocity v is equals to 34 meter per second. Correct answer is option D. 34 meter per second is the final speed of the car. Our next question is question 4. The gravitational field strength is 8.8 Newton per kg on Venus and 3.8 Newton per kg on Mars. An object has weight of 42 Newton on Venus. What are the mass and weight of the object on Mars? We have weight of object on Venus and gravitational field strength on Venus. We will use these two values and find mass of the object. We will use formula W is equals to mg. We will substitute the values and we have mass is equals to 4.77 kg. This can be rounded off to 4.8. So mass of object is 4.8 kg. But mass on Venus and Mars will be same. Mass is same everywhere. That will be 4.8 kg. Now let us calculate weight on Mars using formula W is equals to mg. We'll substitute the values and we get the answer weight is equals to 18.1, which can be rounded off to 18 newtons. So correct answer is option A. Mass is 4.8 kg and weight is 18 newtons on Mars. Let's move on to question 5. A student carries out an experiment to find the density of a rock. Which two measurements does the student need to make to determine the density of the rock? We know density is equals to mass upon volume. To find density, we need mass of the rock and volume of the rock. So increase in mass will be mass of the rock and increase in volume will be volume of the rock. So option A is the correct answer. Student will need increase in mass and increase in volume to find the density of rock. Sixth question. A car has mass of 1500 kg. A constant resultant force acts on the car and car accelerates from 15 meter per second to 20 meter per second in 4 seconds. What is the magnitude of the resultant force acting on the car? We have mass of the car, its initial velocity, final velocity and time. And we have to find resultant force acting on the car. We know force is equals to mass into acceleration. But A, acceleration is final velocity minus initial velocity upon time. That is V minus U upon T. So we will substitute in the formula and we will substitute all the values. We get force is equals to 1875 newtons. So option C, 1900 Newton force is the correct answer because that is the closest to this figure. Seventh question. A metal wire is loaded up to the limit of proportionality. Which statement is correct? A. Hooke's law is not obeyed when the load is increased from 0 to this point. Statement is incorrect as Hooke's law will be obeyed up to this point. B statement. When the load is increased beyond the limit of proportionality, the diameter of the wire will increase. No, beyond limit of proportionality, length increases, diameter will decrease. So that is also incorrect. Option C. When load is removed, wire returns to its original length. Yes, this is a correct statement. That's because when the stress is removed, wire will come back to its original shape. Let us look at the option D also. Up to limit of proportionality, there is no change in the shape of wire. There will be change in the shape. As the length increases, its diameter will decrease. So here option C is the correct answer. When the load is removed, the wire returns to its original length. Next question is question 8. The diagram shows a uniform meter rule Mn pivoted at its midpoint P. Two weights W1 and W2 are hung either side of the pivot. The rule remains balanced. This is the key statement. Which row is correct? We have to say direction of resultant moment about point M, direction of resultant force on the rule. Since we are given the rule remains balanced, that means there is no resultant force and no resultant moment will be there. So correct answer is option D. Direction of resultant moment about point M will be 0 and direction of resultant force on the rule will be 0. Ninth question. Which physical quantity is a vector? We know vector is a physical quantity which requires magnitude and direction. So option A, B, C, mass, density, temperature. They can be described by magnitude alone. They do not require direction. To describe velocity, we need magnitude as well as direction. So option D is the correct answer. Velocity is a vector quantity. Let's see what we have in 10th question. A resultant force of 500 Newton acts for 10 seconds on a car of mass 1000 kg. This causes the velocity of the car to double. So if initial velocity is u, final velocity v will be 2u because it becomes double. So let's see what we have here. We have force 500 newtons, mass of car 1000 kg, time 10 seconds, and we have 2u, or final velocity is equals to twice initial velocity. Let us use formula F is equals to ma. Force is equals to mass into acceleration. But acceleration is v minus u upon t. Let us replace a by v minus u upon t in the formula and substitute all the values. Our v will be 2u. So v minus u is 2u minus u. And on calculating this, we get initial velocity u is equals to 5 meter per second. But in the question, we have to find final velocity of the car, which is v. V is equals to 2u, that is 10 meter per second. So option B is the correct answer. Final velocity of the car is 10 meter per second. Our next question, question 11. A child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? As the car is moving, it will have kinetic energy. So we have to select correct option from C and D. A and B will be incorrect options. Option C says energy changes from kinetic to gravitational potential energy. Gravitational potential energy is mgh. Since m and g are constant and here car is moving horizontally, so even h is remaining constant. So it doesn't change from kinetic to gravitational potential. Correct answer is option D. Energy changes from kinetic to thermal. Due to friction, thermal energy will be developed. Next question is question 12. At time t equals to 0, cannonball is stationary inside a cannon. The cannonball is then fired from the cannon. At time equals to t, cannonball moves forward and the cannon moves backwards. What happens to the total kinetic energy and total momentum of the cannon and the cannonball between time equals to 0 and time equals to t? Let us check total kinetic energy of cannon and cannonball from the question itself. Initially, cannonball is stationary inside a cannon, so kinetic energy is 0. At time t, cannonball moves forward and cannon moves backwards. That means they have kinetic energy. So we can say there is change in kinetic energy. So option C and D are ruled out and we have to select from option A and B. Let us now see about total momentum of cannon and cannonball. Before firing, both cannon and cannonball are stationary, so they have zero momentum. After firing, cannonball has less mass and more velocity, whereas cannon has more mass and less velocity. Both have equal and opposite momentum, so total momentum will be zero again, according to law of conservation of momentum. So we can say momentum remains same and option B is the correct answer. Kinetic energy of cannon and cannonball changes. Total momentum of cannon and cannonball remains same. Question 13. In a small hydroelectric power scheme, 800 kg of water drops through a vertical height of 2.2 meter every second. The electrical output is 10.6 kilowatt. What is the efficiency of the scheme? Formula to calculate efficiency is equals to output by input into 100, and output is given, that is 10.6 kilowatt. Input we have to calculate. Here input will be work done, that is mgh. Mass is given 800 kg, height is 2.2 meter and g we can take as 10 meter per second square. So mgh is equals to 800 into 10 into 2.2, which comes to 17,600 watt. But our output is in kilowatt, so we will convert this also, input also we will convert in kilowatt by dividing by 1000. So we have input equals to 17.6 kilowatt. Let us substitute these two values, output and input, in efficiency formula. So we have 10.6 divided by 17.6 into 100, which comes to 60%. So correct answer here is option C, 60%. 14th question. An object is at rest on a horizontal surface. Which equation is used to calculate the pressure that object exerts? We know formula for pressure is force upon area. Force in this case will be weight of the object and area will be area of contact, because pressure is inversely proportional to area of contact. For example, these two boxes have same weight but their area of contact is different. For first box, area of contact is 200 centimeter square and for second it is 400 centimeter square. Less the area, more the pressure. So option B is the correct answer. Equation which is used to calculate pressure that object exerts is weight of the object by area of contact. 15th question. Smoke particles illuminated by a bright lamp are seen through a microscope. They move about randomly. What causes this motion? Motion exhibited by smoke particles is example of Brownian movement, and this is caused by collision between smoke particles and molecules of air. So option B is the correct answer. Collision between smoke particles and the molecules of air causes this random movement of smoke particles. Let's do question 16. Ether is a liquid that evaporates easily at room temperature. The rate at which ether evaporates can be increased by bubbling air through it. The diagram shows this process. Students gave 3 suggestions why the rate of evaporation increases when air is bubbled through. Student 1 suggests that the temperature of ether is decreased. We know evaporation takes place at all temperatures, but at higher temperature evaporation will be more, At lower it will be less. So student 1 is wrong. Student 2 suggests that the surface area of ether is increased. Yes, due to air bubbles, surface area of ether will increase, and that will increase rate of evaporation. Student 3 suggests that evaporated molecules are removed at a greater rate. Yes, bubbling will make the evaporated molecules removed at a greater rate. So student 2 and 3 are correct. Option C is the correct answer. Our next question, question 17. Some ice is slowly heated and its temperature is measured. A graph is plotted of temperatures against time. Which row describes what happens to the thermal energy and to the temperature in section X? We can observe the graph and see in section X temperature does not rise. That means whatever heat is being supplied is used for phase change. Ice at 0 degrees Celsius is getting converted to water at 0 degrees Celsius. That is, heat supplied is used for phase change. So correct answer here is option B. Thermal energy is gained by ice, temperature of ice stays the same. Our next question, question 18. The diagram shows the apparatus needed for an experiment to determine the specific heat capacity of the material from which an object is made. Which piece of apparatus could be omitted if the purpose of the experiment is to determine the thermal capacity of the object? Let us define thermal capacity first. Thermal capacity of an object is the amount of heat required to raise the temperature of object by 1 degree Celsius. To measure energy supplied, we have to have stop clock, because energy supplied is equals to power into time. To measure the rise in temperature, we need thermometer. Thermometer is needed to measure current for calculating power VI. So what we don't need is balance. We don't need mass. So correct answer here is option B, balance. Our next question, question 19. Both boiling and evaporation involve a change of state from liquid to gas. Which row gives the correct difference between boiling and evaporation? Let's check option A. Boiling, no bubbles are formed. Evaporation, bubbles are formed. Both are incorrect. In fact, it is reverse. In boiling, bubbles will be formed, and during evaporation, no bubbles are formed. Option B says occurs at all temperatures. Boiling occurs at all temperatures and evaporation occurs at definite temperature. This is also reverse. Boiling occurs at definite temperature and evaporation occurs at all temperatures. So option B is also wrong. Option C occurs throughout the liquid. Yes, boiling occurs throughout the liquid. Evaporation occurs at surface only. Yes, that is also correct. It occurs only at the surface. Let us check option D also. In boiling, temperature falls. No, it doesn't fall. In evaporation, the temperature remains constant. No, temperature falls during evaporation. So correct answer here is option C. Boiling occurs throughout the liquid. Evaporation occurs at surface only. 20th question. Which statement describes thermal conduction in a metal by electrons? Let us check all the options. Option A. Atoms and electrons move freely throughout the metal. Atoms do not move. Electrons move throughout the metal. So statement A is incorrect. Statement B. Atoms and electrons vibrate about their fixed position only. Electrons do not vibrate about their fixed position. They are free to move throughout the metal. So option B is also incorrect. Option C. Electrons move freely throughout the metal. This is correct statement. Let us check D also. Electrons remain attached to atoms. Electrons from outermost shell or valence shell are free to move throughout the metal. So statement D is incorrect. So correct answer here is option C. Electrons move freely throughout the metal. Next question, number 21. A tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripples to refract? Refraction is change in the direction of waves as they move. most important property of water which causes this is depth. Ripples travel fastest in deep water. Their speed decreases as they travel in shallow water. This change in speed causes ripples to refract. So correct answer here is option B. Ripples change speed as they move from deep to shallow water. Let us check other options too. Option A. Cold water in the tank is replaced by warm water. There is nothing in the question to indicate what is causing this temperature difference. But anyway, depth of water is the factor which affects change in speed, and this change in speed causes ripples to refract. So option A is incorrect. Let us see option C. Ripples hit the wall of the tank. That will cause reflection of the waves. And option D. Ripples pass through a narrow gap. That will cause diffraction. So option A, C, D are incorrect. Correct one is option B. Question 22. The diagram shows wavefronts of water passing through a gap in a barrier. Which change will increase the diffraction of the wave as it passes through the gap? Diffraction will increase if wavelength is increased, and wavelength will increase if frequency is reduced. So correct answer here is option D. Reduce the frequency of the wave. Frequency and wavelength are inversely proportional. Reduction in frequency causes increase in wavelength, which in turn causes increased diffraction. Our next question, number 23. The diagram each shows a ray of light from an object O passing through thin converging lens. The principal focuses in each diagram are labeled F. Which diagrams are correct? In first diagram, we have ray passing through optical center passes straight through it. It's a correct diagram. In second diagram, ray parallel to principal axis should pass through focus after leaving the lens, but it isn't passing through focus. So this diagram is incorrect. Let us have a look at third one. Ray passing through focus after emerging from lens runs parallel to principal axis. This is a correct diagram. So correct diagrams are 1 and 3, and option C is the correct answer. Our next question, question 24. The diagram shows a ray of light inside an optical fiber approaching point X. The light is totally reflected within the fiber. The refractive index of the material of the fiber is 1.39. Which condition ensures that total internal reflection occurs? For total internal reflection to occur, angle of incidence at point X, that is angle Q, should be greater than critical angle. Let us first find critical angle. We are given refractive index of optical fiber. So refractive index is 1 by sine of critical angle, or we can say sine of critical angle is 1 by n, that is 1 by 1.39, which comes to 0.719. Sine inverse of 0.719 is approximately 46 degree. So angle Q has to be greater than critical angle, which is 46 degree. Let us consider the options. Option A, Q is less than 45 degree. It's a wrong option. Option B, Q greater than 47 is a correct one. Option C, P greater than 47. Now here angle P and Q are formed between normal and tangent. So together they make 90 degree. If P is greater than 47, then Q will be less than 43. And we want Q to be greater than 46. So C is a wrong option. And in option D, P and Q are equal. Since together they make 90 degree, if P and Q are equal, then each will be equal to 45. That makes Q less than 46. So option D is also incorrect. Option B is the correct answer here, because only here angle Q is greater than critical angle. So Q greater than 47, option B is the correct answer. Next question, question 25. An eclipse of sun happens when moon comes between earth and the sun. Which statement is correct? In option A, B, C we are asked whether infrared radiation, ultraviolet radiation or visible light coming from sun will disappear first. But these are all incorrect since moon is blocking the path of rays or any radiation from the sun. Infrared radiation, UV radiation and visible light from sun all disappear at the same moment. So option D is the correct answer. Let's do question 26. The diagram shows air particles in a sound wave. Which row correctly identifies the position of a compression and position of a rarefaction? Let's check option A. X is a compression. We know compression is a part of wave where particles of medium are more dense or they are closest. So here we can see in part X, section X of the wave, particles are closest, so it is compression. Y is a rarefaction. Rarefaction is a part of wave where particles of medium are less dense or they are spread out. We can observe that in section Y of the wave, particles are spread out, so it is a rarefaction. So first option itself, that is option A, is the correct answer. Section X of the wave is compression and section Y is rarefaction. Next question, question 27. Two isolated metal spheres are both negatively charged. The spheres are brought close together but do not touch. Which diagram shows the charge distribution on the spheres? Let us check all the options. Option A. Both spheres are negatively charged. Like charges repel each other, but here they are shown attracting each other. So option A is incorrect. In option B and C, negative charge from one sphere has moved away and from other sphere it hasn't moved away or repelled. Negative charges from both spheres should have repelled. So option B and C are also incorrect. In option D, negative charges have repelled each other. So option D is the correct answer. Our next question is question 28. Two separate circuits have different power supplies. Both power supplies provide same magnitude current. Power supply P has an electromotive force of 1.5 volts and power supply Q has an EMF of 3 volts. Which statements about Q are correct when compared with P? Let us check first option. Q supplies twice the charge per unit time. We know charge per unit time is current and we are also given both power supplies provide same magnitude of current. Option 1 is incorrect. Let us check second statement. Q supplies twice the energy per unit charge. EMF is work done on unit charge. Since power supply Q has double the EMF, so work done by it or energy supplied by it also will be double. So statement 2 is correct. Let us check statement 3. Q supplies twice the energy per unit time. We know power is equals to V into I. Here V is double, so power will also be double and power is energy supplied per unit time. Q will supply twice the energy per unit time. Statement 3 is also correct. So correct answer here is option D. 2 and 3 statements are correct. 29th question. The diagram shows a piece of metal resistance wire. Which wire made of the same metal has smaller resistance? Let us check all the options. Option A. A wire of same length with larger diameter. If the diameter is large, resistance will decrease. Option B. A wire of same length with smaller diameter. If diameter is smaller, resistance will increase. Option C. A wire of greater length with same diameter. If wire is of greater length, resistance will increase. Option D. A wire of greater length with smaller diameter. Diameter is smaller, resistance will increase. In the question we are asked which wire made of the same metal has smaller resistance. So correct answer here is option A. A wire of same length with larger diameter will have smaller resistance. 30th question. Which label component in the circuit shown controls the brightness of lamp X? This answer is quite simple one. Component labeled B is a variable resistor or rheostat. It has resistance wire which can be increased or decreased in length, thereby increasing or decreasing the current. So this can be used to control brightness of lamp X. Next question, question 31. A circuit includes a battery, two identical resistors and 5 ammeters P, Q, R, S and T. Which statement about the readings on the ammeters is not correct? About current in the circuit, we have to remember 2 points. First point is current in each component of series is same. Since P and Q are in series, both will have same current and same reading. So statement A, which says P has greater reading than Q, is incorrect. It's incorrect statement but correct answer of this question, because we have to select a statement which is not correct. Let's check other statements too. Second point which we have to remember is total current in the main circuit is sum of currents in the branches. Current in ammeter P will be sum of currents in these two branches. So reading in P will be greater than any of the readings of R or S or T. So option B, C, D are all correct statements. P has greater reading than R, P has greater reading than S, P has greater reading than T. So correct answer here is option A. P has greater reading than Q is incorrect statement and correct answer. Let's do question 32. An electrician sets up a potential divider circuit in the fridge so that when the fridge door is open and light from the room enters the fridge, a warning light turns on. Which component does the electrician need in addition to a variable resistor? Correct answer here is option A, light dependent resistor. This is required so that when fridge door is open and light from room enters the fridge, a warning light turns on. Question number 33. Two NAND gates are joined together as shown. Which single logic gate is equivalent to this combination? NAND gate is combination of and NOT gate. Single logic gate equivalent to this combination, that is two NAND gates in series, is AND gate. That means option A is the correct answer. Let us discuss this in more detail. We'll take input 1 and 2 as 1, 1. AND gate will give output 1, but this is NAND gate, so output will be 0. For next NAND gate, inputs are 0, 0. So output will be 1 here. So for input 1, 1, we have output 1. Let us check from the given options which one gives this result. For AND gate, 1, 1 input will give output 1. NAND gate, input 1, 1 gives 0 output. NOR gate, 1, 1 input gives 0 output. OR gate, if input is 1, 1, output is 1. So we have two options which have given same result, that is AND and OR gates. But if you take inputs 0, 1 or 1, 0, output for OR will be different and you will get matching results with AND gate. So correct option here is option A, AND. That will be equivalent to this combination of NAND gates. Let's move on to next question number 34. The diagram shows an electric drill and safety guard. The drill requires the logic circuit shown. Let us have a look at the components marked in electric drill. Safety guard in closed position, drill, electric motor. Now the question is, circuit must only allow motor to start when the safety guard is closed. If safety guard is not closed when the starting switch is on, the alarm must sound. Which logic gate is missing from the circuit? We have two situations here. In first situation, starting switch is on, safety guard is closed, motor will be on. In second situation, starting switch is on, safety guard is not closed, that means open, then alarm must sound. Check inputs and output when motor is on. Starting switch is on, safety guard is closed. Input at AND gate will be 1, 1 and output will also be 1, motor will be on. Let's check inputs and outputs at missing gate when alarm should be on. Switch is on, input at the missing gate is 1 and when safety guard is not closed, that is open, input 0 passes through NOT gate which makes it 1. So input at missing gate is 1, and we need output 1 for alarm to be on. So for input 1 1, output will be 1 when missing logic gate is AND. That is option C, AND gate is the correct answer. Question 35. Two magnets are placed near a current carrying coil. The diagram shows this experimental arrangement and current direction in the coil. Which statement is correct? Ends here will develop polarity depending on direction of current. If current is in clockwise direction, it will be south pole, and if that current direction is anti-clockwise, it will be north pole. You can see south pole is developed near south pole and north pole is developed near north pole. Since like poles repel each other, both magnets X and Y will be repelled by the coil, and correct answer here is option B. Both X and Y are repelled by the coil. Question 36 is our next question. Two circuits are set up as shown. The iron rods are placed close together and are able to move. What happens to the size of gap at X when switch S is closed? In this figure, current is moving from positive to negative direction in a clockwise manner. In figure on the right also, current is moving from positive to negative in clockwise manner. So two extreme ends develop south polarity and two ends in the middle will become north poles. Since like poles repel each other, size of gap X in the middle will increase. So correct answer here is option C, it increases. Let's see what we have in next question, which is number 37. When a current carrying conductor is placed in a magnetic field, it experiences a force. Which statement about this force is correct? When current carrying conductor is placed in magnetic field, three things, that is magnetic field, direction of current and force, all three are perpendicular to each other. Option A, B, C say that something is parallel. So all these three options are incorrect, and the correct answer is option D. It is perpendicular to both magnetic field and direction of the current. That is, force is perpendicular to magnetic field and direction of current. Next question, question 38. When a beam of alpha particles is incident on a thin metal foil, most of them follow a path represented by path X in the diagram. A small number of alpha particles follow a path represented by path Y in the diagram. Which row correctly describes a conclusion that can be drawn from each of these observations about the structure of the atom? In path X, since particles are able to pass straight without any obstruction, it means it is an empty space. And since most of the alpha particles are able to pass straight, that means atom is mostly empty space. So we have to choose between option A and B. A small number of alpha particles following path Y are reflected back. That means atom contains something that repels alpha particles. So correct answer here is option A. Most follow path X shows that atom is mostly empty space, and some follow path Y. It indicates atom contains something that repels alpha particles. Let us see what we have in next question, that is number 39. Nuclear fusion is a reaction that takes place in stars. Which row describes this reaction? For example, in sun, hydrogen nuclei fuse together to form helium. That means lighter nuclei fuse together to form a larger nucleus with release of lot of energy. So correct answer here is option D. Atomic nuclei join together to form a larger nucleus and energy is released. We have come to last question of the paper, that is question 40. When radioactive isotope is set up close to a count rate of 38,000 counts is obtained. The table shows the count rate from the isotope over 3-year period. What is the half-life of the isotope? At 0 year or 0 time, count rate is 38,000. We have to find when will it become half of 38,000, that is 19,000. In year 1, it becomes 26,000. So time required for it to become 19,000 will be more than 1 year. In year 2, count rate is 17,000. That means it has already crossed half-life of 19,000. Time required will be less than 2 years. So correct answer here is option B. Half-life of isotope is more than 1 year but less than 2 years.